You know, every single time you scroll through your social media feed, or you check your bank account, or you track a package that's on its way to your house, there is this hidden language working tirelessly behind the scenes. It's a language called SQL. And the crazy thing is, it's part of an accidental empire that, well, it pretty much runs our entire digital world.
So let me ask you a question. What language from the 1970s, the 1970s, do you use every single day, probably without even realizing it? Well, you guessed it, it's SQL. And the story of how this, 50-year-old technology came to totally dominate our modern world, it's just incredible. So let's dive in.
Okay, so to really get why SQL was such a game changer, we have to jump in our time machine. We've got to go back to the world before SQL. And trust me, it was a world of pure data chaos.
I mean, you've got to picture this. In the 1960s, data wasn't just floating around in the cloud. No, it was physical. It lived on stacks of punch cards and these massive magnetic tape reels. So what that meant was, if you needed to find, say, one single customer's record, the computer had to start at the beginning of the tape and read the entire thing just to find that one piece of information. It was so slow, so clunky, and unbelievably rigid.
And at the very heart of this nightmare was a problem called physical dependency. It basically meant that every single program had to know the exact physical, nuts and bolts location of the data it needed. Think about that for a second. If you so much as upgraded your hardware, you had to go back and rewrite all of your programs from scratch. It was a total and complete mess.
But then we get to a turning point. In 1970, this brilliant researcher at IBM named Edgar F. Codd published a paper that was about to change absolutely everything. He laid out this revolutionary blueprint for a totally new way of thinking about data.
Codd's idea was radical, but at the same time, it was just beautiful in its simplicity. He basically said, hey, let's separate the question of what data we want from all the messy details of how and where the computer is storing it. This wasn't just an improvement, it was a complete paradigm shift.
And just look at the difference here. The old way was all tangled up with the physical storage. The tapes, the cards. Programmers were stuck deep in the weeds, always worrying about the how. Codd's new relational model, it focused purely on the data itself. It was logical, it was elegant, and it freed programmers to just focus on the what.
So you might hear this term COD used, a relation, and it sounds kinda academic and complicated, right? But really, it's just a fancy word for something we all understand, a simple table. Just like this one. You've got your data organized into neat rows and columns. You could have one table for customers, another for their orders, and then you just link them together. It's so intuitive, so clean, and it was the bedrock of his whole theory. So, IBM, they see the absolute genius in Codd's theory, and they launched this project called System R to try and build a real database based on his ideas. But of course, this brand new kind of database, well, it needed a brand new language to talk to it.
And their goal was just unbelievably ambitious for the time. These two researchers, Donald Chamberlain and Raymond Boyce, they wanted to create a language that was so simple, so intuitive, that you didn't even have to be a programmer to use it. The idea was that a manager or an analyst should be able to walk up and get the data they need directly.
And this is what they came up with. A language they called SQL, which stood for Structured English Query Language. Just look at that sentence. It reads almost exactly like plain English. You're not telling the computer how to find the data, you're just declaring what you want. This was completely and utterly revolutionary. Okay, now here is where the story gets really juicy. IBM has this world-changing technology on its hands, but they're treating it like a science fair project. And they were about to learn a very hard lesson. Some ideas are just too good to stay locked up in a research lab. And here's the David and Goliath setup. You've got IBM, this slow-moving giant, and they publish all their research publicly. But all the way across the country, the sharp, ambitious entrepreneur named Larry Ellison reads those exact same papers. And he doesn't see a research project, he sees a commercial blueprint. And his tiny new startup, Oracle, was going to build it first. And boy, did they move fast. In 1979, Oracle launched the world's very first commercial SQL database, beating IBM to market with its own invention. Ellison's aggressive go-for-broke strategy totally paid off, and Oracle just exploded, dominating the market. The message to the rest of the industry was crystal clear. Adopt SQL or you're going to get left in the dust.
So that brings us to the final chapter of our story, how this language, born in a research lab and commercialized by a competitor, ended up becoming the undisputed, enduring standard for pretty much the entire world of data.
But, with everyone from Oracle to IBM to a dozen other companies all building their own SQL databases, a new problem started to creep in: fragmentation. See, each company's version of the language was just slightly different. That meant your skills, or your code, couldn't easily move from one database to another. The industry desperately needed a universal standard.
When you boil it all down, SQL's incredible success really stands on 3 pillars. First, it's declarative. You just say what you want, not how to get it. That makes it super powerful but still easy to learn. Second, it got standardized in 1986, turning it into the universal language for all data. And third, it's all built on COD's rock-solid mathematical foundation, a foundation that has proven to be absolutely timeless.
Just stop and think about that for a second. 50 years. In the tech world, that is an absolute eternity. I mean, we see frameworks and languages become obsolete in just a few years. But SQL isn't just surviving after all this time. It is thriving. It's the literal backbone of our entire digital economy. So, from a research paper to the engine of the global economy, SQL is just this incredible testament to a simple, elegant idea that accidentally took over the world, which, of course, leaves us with one final thought to chew on. After 5 decades of total dominance, what in the world could possibly come next to dethrone this accidental empire?